I decided to make a video going over some homework questions for you guys since I was gone. So I have them written up here. These are the ones that I think you may have had issues with, or they should kind of jumpstart the rest of the problems if you are having issues with them as well. Okay, so these are all from section 6-8. So I got 6 of them here, and I will go through these 4 from 6-9. Okay, so you should be able to recognize that these are pretty similar to the stuff that we've done before. Okay, we just have natural logs floating around now. So on 28 and 29, you just had to condense them, okay? So put them into one single logarithm or one single natural log, okay? First thing we need to do, bounce exponents up top. Okay, so that becomes a 4 up there and a 6 there. Then you can rewrite it if you want to make it look a little bit nicer. So we have 1/3 to the 4th power minus natural log of 1/9 to the 6th power. And then you're going to put those together. Okay, so this sign right here, that subtraction sign means we're going to put them together with division. So it looks kind of crazy when you put it together, but you can use your calculator to help you out. We have natural log, and then we're going to have 1/3 to the 4th power. So that's 1/81. That's going to be divided by 1/9 to the 6th power. Okay, so 1/9 to the 6th power turns into pretty big number. So 1/9 to the 6th power would be 1/531,441. And then you can just use your calculator to simplify those two. So you could do 1/81 divided by 1/531,441. And that gives you 6,561. So we have the natural log. Rewrite this down here. So we'll have the natural log of 6,561. And that is how you're going to rewrite that logarithm. And then if you wanted to, you could plug it into your calculator to see if you get the same answer here as we did here. You can check those from beginning to end. Second one is a little bit nicer. You don't have those crazy fractions, but we're getting used to using our calculator a little bit more now. So exponents go up top, just like we did in the last one. Rewrite it. Natural log of 1/2 to the 7th power plus natural log of 2 to the 5th power. And we can simplify those. But this sign right here means that we'll be multiplying them. Okay, so we put them together into one logarithm, or one natural logarithm, okay? And it'll be 1/2 to the 7th times 2 to the 5th, which you can just put that in your calculator. But that will be 1/4, I'm pretty sure. So 1/2 to the 7th power gives you that times 2 to the 5th. So it's 1/4. Yeah, so it's natural log of 1/4. That is your answer. So again, you can take it, plug both of these into your calculator, see if you get the same answer in the end. So that's how you would check them. Moving on to solving equations with E. For number 32, we did one exactly like that in class, but I gave you 2 different ways to solve it. You can do whichever one you think is easier. So I like the one where you take natural log of both sides, so that's what we're going to be doing. So first you want to move the 3 over because we have to isolate that E. We have 6e to the x equals 38. Divide by 6 on both sides. We have e to the x equals 38/6. We can take a 2 out of both of those and it will give me 19/3. Now we have that e by itself, So we need to take natural log of both sides because we want to get the x out of there. So remember, this stuff right here, natural log of e, that's just going to cancel out. And then that x is what's going to go in front, which will just give you with an x for that side. Just leave you with an x there. So we'll have x equals natural log 19 over 3, which you can just plug that into your calculator and approximate the value. If we do that, natural log of 19 over 3, we get about 1.845. And I don't remember for sure what value it tells you to approximate to in the book. I'm going to go to the 10,000ths here just to kind of give myself a little bit more bulk to my answer. 36 is very similar to 32. So we want to isolate that exponential. Get that guy by itself. So the first thing we need to do, move the 7 over. And we have 6e to the 4x equals, so 4 minus 7, that's a negative 3. Divide both sides by 6. And we have e to the 4x equals 3 over 6, that's a negative 1/2. Then we want to natural log both sides. Okay? And when we do that, you might recognize some problems here. So if you natural log both sides here, you end up with a no solution type scenario. Let's double check to see if that is the way it's supposed to be. So number 36 is in fact no solution. So when we're looking at this one, just like the last problem, we take natural log of both sides, natural log of both sides. That's going to cancel, right? But then we would have 4x equals natural log of a negative 1/2. Okay? And we kind of hammered this a little bit yesterday. This right here can't happen. You can't have negatives in a natural log. All right? Because those graphs, that would be passing my asymptote, which is not a legal move here. So that right there tells me no solution. All right, so you can't have negative inside those natural logs. Moving down to 52 and 53. So what you're supposed to do with those two problems is you're supposed to expand them. You're supposed to expand the logarithms into the simplest form. Okay, so first thing here, we're looking at this one. So we need to expand that. We got two things in there. We have a 12 and we have an x squared. So we need to give each of those their own natural log. And times natural, or not times, plus. Go with the plus because multiplication means addition. So natural log of x squared. Then we can go the next step. Break that variable out front. So we have natural log of 12 plus 2 natural log of x. And that is all the further that we need to go. So we're kind of working backwards from what we've been doing. We're taking a logarithm and we're expanding it. So we needed something, we needed a logarithm for the 12, and we needed a logarithm for that x squared, or a natural logarithm, rather. Okay. 53, that one has a little bit more steps. So we have a 16 and a 125. Okay, so the first step will be splitting that up with subtraction. So natural log of 16 minus natural log of 125. Now, if you looked at the textbook answer, that was not it, right? Because they have natural log of, or 4 natural log 2 minus 3 natural log 5. So this is how they get it. They rewrite the 16 and 125 as powers of a number. So the simplest base for 16 would be a 2. So I can rewrite that as 2 to the 4th power. And then I can rewrite the 125 as 5 cubed. So I have natural log of 5 cubed. Okay? In parentheses there too. So remember, exponents can bounce out in front of the logarithms. So these guys, that 4 goes out in front. That 3 goes out in front there. So that's where that answer comes from. So it's 4 natural log of 2 minus 3 natural log of 5, just like they have in the textbook. Okay? So the goal here is if you have a power of something, like we had for our 16 and our 25, or 125, excuse me, that you have to rewrite them as the power of the base. So the 12, we didn't do that over here because 12 cannot be rewritten as a power of anything. Okay? 12, you could split that up a little bit more as a 2 squared times a 3 if you wanted to, but they're not powers of anything, so you don't have to do that. Okay, so that is the homework questions that I felt you would have from 6-8. Now jumping to 6-9. So those 4 right there. So taking care of these ones. So number 12, I have log base x of 32 equals 5/2. So you got 2 options. You can take both sides of the power of x, or you can dab it. So I'm just going to dab it here. Boom, boom. So that gives me x to the 5/2 power equals 32. We haven't had one of these for a while. Okay, we had one of these on the last test. And it was actually bonus. But you can sit here and think to yourself, how can I get a 32 from something being raised to the 5/2 power? Well, you can do a little bit of guessing and checking to see if you get it in your calculator, or you can do the inverse of exponents, which we did a while ago. So how would I undo that exponent? Okay, well that's like a square root and then to the 5th power. You could square it and then take the 5th root, which I wouldn't recommend that. I would just do this. So take both sides to the 2/5 exponent. Okay, both sides to the 2/5 exponent, because then these are going to cancel. Right? Because the power to a power, they multiply. So 5/2 times 2/5, those are inverses, so they turn into a 1. So we'll have x equals 32 to the 2/5 power. Back to those rational exponents. So that 5 means I'm taking the 5th root of 32. So 5th root of 32, and then I'm going to square that. Okay? 5th root of 32, that turns into a 2. 2 squared, that gives me a 4. That's your answer. We can use that 4 and we can plug it back into the top up here and check it out, and you can get the you can see if you get that 5/2 using the change of base formula. So on to number 16. This one's kind of a trick question in a way, because you really don't have to do anything, because you can recognize where we have this chunk right here. They give you a problem with a -8 inside of a logarithm. That's automatically no solution, okay? But for you guys that went through it and just kind of persevered to see if you can get an answer, I will show you what you should do. So first thing you got to recognize, same logarithms on both sides so we can cancel them out. Then we get x squared minus 6x equals -8. So whenever we have an x squared and an x floating around in a problem, you want to put everything on the same side and factor. So we're going to move this 8 over. Move that 8 over to the left. And that would give me this equation. And then you factor it. So 2 numbers that multiply to give me a +8 and add to give me a -6 would be 4 and 2, -4 and -2. So the solutions that we end up getting are x equals 4 and x equals 2. But when you plug them in, you won't get, well, you might get the same thing. So let's check if we plug in a 4. That would be 16 minus 24. That ends up giving me a -8. So you might think that that one works, because that looks like we'll have log base 6 of -8 equals log base 6 of -8. Again, you can't have negatives, so it was a no solution right away. If we did the 2, so this would be 4 minus 12, which again, that would give me a -8. So it's kind of a trick question, because you have to recognize this at the beginning, that it's no solution. But if you were to keep going, you get a 4 and a 2. Those answers are out because of that. Okay? So that problem is kind of an interesting one. On 25 and 29, they are inequalities. We did not go through any inequalities in the problems that I assigned or in the notes from yesterday, so I'm just going to kind of take care of a couple of these and show you how they work. Okay, so 25, you have log base 2 of x is less than or equal to negative 2. So we can exponentiate this thing, just to show you real quick what that would look like. Remember, you take the base, that 2, and you're going to use that to raise both sides of the power of 2. So it would look like this. 2 log base 2 of x is less than or equal to 2 to the negative 2 power. When I do that, these will cancel, and I get x is less than or equal to 2 to the negative 2 power, which that means x is less than or equal to 1/4. Okay, that's the answer that you should get if you're just kind of crunching through it. If we did it the other way, so that's exponentiating, remember, I'll show you how we do it the other way and get the same answer. So the other way is just to dab it. Let's move that out of the way. So we dab it, boom, boom, you get 2 to the negative 2. And remember, your signs need to be pointing at the x all the time. So 2 to the negative 2, so is going to be going greater than or equal to x. Because we're going to be pointing at that x. We follow the x with the inequality signs. So we'll have, again, x is less than or equal to 1/4. Either way, get you to the same answer. Now there is an extra piece to these things. Because what kind of numbers can you have inside of a logarithm? What kind of numbers can we plug into the x there? You know that you can only have positive numbers. So how do we say positive numbers as an inequality? X must be greater than or equal to, actually not equal to, just greater than. Okay, because we can't have a 0 either. It's got to be greater than 0. We can't have a 0 in there or negative. It's got to be all positive numbers. So we have to put these two inequalities here together to make our answer. Because this one here says I need stuff that's less than 1/4. This one here says I need stuff that's bigger than 0. So let's put them together. So way back in the day we did these, the smaller number goes on the left, the x is in the middle, and then the bigger number is on the right. That right there is your solution. So a lot of the times with these you end up with compound inequalities like that because of your constrictions or your restraints with the logarithms. So 29, looking at that, you got the same log on both sides, cancel it out. Boom, boom. Then we have x plus 2 is greater than or equal to 6x minus 3. And then we just kind of solve it like a normal inequality. You put the x's on the left and the numbers on the right. So minus 6x minus 6x minus 2 minus 2. And that will give us a negative 5x. It's greater than or equal to negative 5. Divide both sides by the negative 5. Remember what you're supposed to do with your inequality signs then. So we get x is less than or equal to 1. So that's the main answer. Then we got to look at our inequalities. So you have to make a little tiny equation with each one of them because we have to be bigger than 0. So x plus 2 is greater than 0, so x must be greater than a negative 2. All right, we have that restraint. Let's check out this one. So 6x minus 3 is greater than 0. Add the 3, we get 6x is greater than 3. X has got to be greater than 1/2. Okay, so we have those three inequalities that we have to use for this problem. All right, so then we need to look and see which one is the bigger number. Okay, so which one's the bigger number out of this one? We have a negative 2, and then we have a 1/2. Because if we have a negative 2 and we plug it into here, that don't work, right? Because that asks for everything that's bigger than a 1/2. So which of those has the bigger number? That would be this one right here. So we have to make an inequality with that one and that one together. Okay, so we got to be bigger than a 1/2 and less than 1. So the 1/2 goes on the left. We are greater than that, x in the middle less than or equal to 1. That's your solution for this inequality. All right, double circle that one. So those are a little bit harder because they have a little bit more pieces to them. I don't have any of those on the test. I just wanted you to see them. That's why I gave you a couple of them, see if you could persevere through them and give them a shot. So those are your homework questions that I felt you might have questions on. So hopefully that helps.